Hi, I'm Darren and welcome to Level Up EE Lab. Well, it's been quite a while since I repaired and restored that Heathkit HW-101, so it's high time for another challenging project. So, how about this DX-60 that needs a lot of care and attention? Let's check it out. As compared to my HW-101, the DX-60 is a considerably simpler rig. For starters, it's just a transmitter, not a transceiver. And furthermore, even though it covers the classic amateur HF bands, it does not include a VFO. You have to provide an external one like the HG10 or plug in some crystals to set the transmit frequency. And it only operates on CW and AM modes. No single sideband here. Introduced in 1960, it was eventually replaced by the DX-60A and later still by the DX-60B, and could still be purchased as late as 1975. You could start as a novice using the DX-60 with crystal control and set it to no more than 75 watts for CW. A 15-year production run is impressive, and there are plenty of favorable opinions of the DX-60 online. However, there are a number of issues that hams have found with it. Some are inherent to the design, but quite a few seem to have erupted due to use and time. I'll get into the big issues later. But first, let's do a visual assessment of the rig. The front panel is in good shape. The knobs, however, not so much. Most are split and cannot be tightened down anymore. And something is definitely broken on the load control. Visually, the meter looks fine, but I'll definitely have to check it functionally. Around back, we find 5 sockets for plugging in crystals in a VFO. The chassis condition is a bit alarming. It's starting to rust in several areas. No aluminum or copper-plated steel here. It's probably just zinc-plated steel. The case is in fair shape. It's got a lot of scratches, but the paint color is still holding up. The story is getting progressively worse here on the top side of the chassis. That's not regular rust right there. That's likely caused by vermin excrement. Nasty. At least the tubes and tube shields are all present. I'm concerned about the amount of rust on the transformer laminations. I can sand it down and paint it if it's just cosmetic, but here in the back I can see what looks like some of the laminations are starting to separate. If the rust is spreading inside, that could be bad news. Let's check out the bottom side of the chassis. Okay, so where to begin? It looks largely like a stock rig. Even the electrolytics look like they're still the originals. Nothing looks burnt or overheated except for this busted power resistor right here. It's seen better days. The wiring is in poor shape. The main harness looks like it's been split open and many of the wires look like later replacements. The crystal select and band select switches are really stiff to turn, but the contacts don't appear to be damaged. The function switch, though, is all bad news. In fact, it's terrible news. It's trashed. It won't even turn without extraordinary effort, and the front side contacts are no longer working. They've been hot-wired. That's one of the big issues with the DX-60 that I mentioned earlier. The function switches in these rigs are notoriously weak. Apparently the way Heathkit deployed them in the circuit made them vulnerable to arc erosion. And naturally, there's no modern drop-in replacement. Jumping back to the top side, let's inspect the stuff inside the high voltage cage. Well, at least there's a 6146 present. But, judging by the condition of the tank coil, that poor output tube might be cooked. Look at this end of the coil. The supports seem to be melted. Now it's obvious why the load control is so loose. The shaft coupler is broken. And that's yet another unobtainium part, so fixing that will be challenging. So right away it's obvious this rig has a lot of big issues. Now, I can likely find ways to overcome everything I've found so far, which then leads into the next 2 items I have to check, the meter and the transformer. Now, they both need to be in good working condition in order for this project to move forward. A nice plus at this point would be if the 5 tubes are still good, and since I need to pull them off the chassis to continue my assessment anyway, I might as well run them through the tester and see how they do. Alright, the results are in on testing the 5 tubes, and there's one concern that I see here. I'll explain it here in a minute, but let's talk about the good stuff. So for the 5 tubes test just fine. That's 6 CL6s. one 60E7, one 12AX7, and the one that's got some questionable results is unfortunately the final output tube, the 6146. As I've said before on my channel, anybody that uses tube testers for a while knows that just because a tube passes doesn't mean it's going to work in the circuit, but if it fails, it's almost certainly going to have problems. You've got something wrong with it. And the issue that concerns me here on the 6146 is the grid leakage. Now I'm not showing that right now. I've got it set on emissions. So emission is the top scale here, and anything in the green area is good according to the TC162 meter. There are numbers here, but I don't obsess over the numbers. I'm looking to see if it's in the good region. Now switch it over to grid leakage, and it's in the bad region. It's the lower scale, but it doesn't stay there. Now I've seen a very odd behavior here. This needle will very slowly move back over to the good range, and I think it's just slowly decaying. Whatever micro current that is leaking across the grid is slowly decaying. So that might be a false positive. The reason I say that, I typically will see the opposite behavior if there truly is a problem with grid leakage in a tube, meaning it'll start down here in the good region, meaning low grid leakage, but if you let it set for sometimes up to 10 minutes, that needle will slowly move up and up and up and get into a higher amount of grid leakage and stay there. This tube is doing the opposite. So I think that might be a false positive result, not sure, but I'll take it. Certainly going to move forward with the rest of the examinations on this rig. Next up is the meter, and the verdict is kind of a mixed bag here. So it's working. I've got it isolated from the rest of the circuit, and I've got it connected to my 2718 in the background with I think it's a 5.6K dropping resistor and my digital multimeter here set to measure milliamps. So right now it's spot on 1 milliamp going through the whole circuit, and you can see where the pointer is. So I can vary the voltage in the background here, and as the current goes down, the meter needle goes down just like it should. So that part's fine. The part that has me perplexed though is every reference I can find for what this meter is supposed to be, it's supposed to be 1 milliamp full scale. This is 1 milliamp approximately half scale, and in the lower range it seems to be pretty smooth, but I get here in the upper range and it's a little sticky there. So I am concerned that this meter has been abused and it's no longer reading correctly. That's what I would presume here, because I just can't find any reference online that says that anything other than a 1 milliamp full scale meter was ever used on any versions of the DX60. So I'm going to consider that a fail for the time being. I need to make sure the transformer is okay in this DX60 before I move forward with any plans for restoration. If it's got an open winding, then this project pretty much is going to come to a grinding halt. The transformer is very unique in this rig. Like a lot of vintage tube rigs, you're not going to be able to find a modern day drop-in replacement. So what I like to do, obviously the most simple thing to do is just check the resistance on the primary and all the secondary windings. That would be a basic check, but I like to take it a step further and actually put AC voltage on the primary and measure the voltages on the secondary. And I'm doing that with no load. You can see one of the caps, protruding up right here that I cut to isolate, and I actually cut out some of the other caps that are in there just to be able to isolate the secondary from any of the circuits that are in the rig. And then in this case, because just how unique this transformer is, there are 4 separate secondary taps that I need to monitor. Now I just got voltmeters hooked up here. I got 4 voltmeters pressed into service here so I can look at everything simultaneously. I like to do this because you could just check it with a single voltmeter, but that's a little more risky because you're probing around, in some cases, some very high voltage, and it's just safer if I have everything instrumented and to keep my hands away from the rig while I've got AC voltage applied to it. Now I could take it a step further and actually put load on all of the secondary windings and check them under current. Now I just don't have enough loads to be able to do that, and you'd have to, of course, calculate what the right resistance would be. In some cases you may be dissipating quite a bit of power, but I think this is good enough to give me confidence to move forward if it passes. Here's how each of the 4 meters are hooked up. There's actually 2 6.3 volt AC secondary taps on this transformer. One is used to power the filaments in the tubes that are in the rig. That's connected to the IM13 in the upper left-hand corner. And then the second one that's used just to power the tube filaments and anything you plug into the accessory socket, that's the little tiny DMM in the lower right-hand corner. And you can see the leads are literally just setting inside of that accessory socket. The third secondary filament, it's 110 volt AC for most of the, actually I think it's for the bias, if I remember right, in this rig. That is hooked up to the other DMM in the lower left-hand corner. And then lastly, my Keithley in the upper right-hand corner is connected to the highest voltage AC, the 260 volt AC secondary. And of course, I'm using my dim bulb tester to provide the AC power to the primary, and very good practice to use this because it gives me both a variable voltage and current limiting by using the light bulb in series with the primary. So let's go ahead and turn it on and turn it up.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
Alrighty, I'm seeing some voltage coming up on the secondary, so that's good. Let me keep bringing this up. There's some keeping an eye on all 4 meters at the same time here, looking for anything that drops out. Got about 70 volts on the primary. I'll keep going until I get to 110, and then I'll stop there. Okay, that's close enough. And before I ran this test, I checked the meter because it's not terribly accurate on my dim bulb tester, but at 110 volts AC, it corresponds within a volt or two of my other references. So I know, at least at that data point, it's pretty darn close to 110. So let's see what we got. On the 2 6.3 volt secondaries, one's at 6.2. That's on the tiny little meter in the lower right-hand corner. And then my IM13 upper left is showing just over 6 volts. I know you probably can't see the needle very clearly, but trust me, it's just about 6.5 volts. So that's good. So both of those 6.3 volt AC secondaries are working. The other DMM, this guy right here, showing 105 volts. It should be 110. That's close enough. And then lastly, the Keithley, this guy up here, should be 260, and it's showing to almost 250. So that's also acceptable. So this is a very good sign. This is telling me that all 4 secondary windings in the transformer are working fine, so I can move forward. Okay, now that I know that the transformer seems to be working okay, and that I've got my arms around what hopefully are all the other major issues with this rig, I can decide on what I'd like to have for the final condition of this repair project. And what I've decided to do is to repair this rig back to normal operating condition with a minimal emphasis on using original replacement parts for the stuff that's broken. Given the rig's present condition, I think that's the appropriate choice. To do otherwise would require scrounging the world to try and find really rare replacement parts, which may even lead to having to acquire a few more DX60s to use as parts units. Now, if this had a better starting condition or maybe sentimental value, then maybe going down that path would be fine. But in this case, it doesn't. So here's my plan of attack. First, I'm going to strip the rig down to a bare chassis, just like I recently did on my Johnson Viking Adventurer. This will let me address the corroded chassis and transformer. Now for the transformer, I think I can just do some sanding and painting and be done, but the chassis is another matter. Not sure yet what I'll do. I'd really like to have it replated, but that's probably not going to be practical, so plan B is to paint it as well. Next is to save or supersede all of the broken items. The meter, the load drive, the function switch, and so on. If I can repair them and save them, then I will. But if not, I'll supersede them. I'll substitute a modern equivalent that will perform the same function. Another benefit from stripping the rig down to a bare chassis is that'll let me replace all the wiring. The existing wiring is in poor shape, so replacing it all makes sense. I'm seriously considering even making a nail board and lacing a new harness, so that'll be a first-time adventure for me. And finally, I do want to incorporate a few modern features and improvements that folks have made to the DX60 over the years. At a minimum, I want to add a push-to-talk relay conversion like Terry shows over on his D-Lab Electronics YouTube channel. That's a must-have feature as far as I'm concerned, and the mod isn't that difficult. Also, Janice over at wirelessgirl.net has a great page dedicated to the DX60 with a ton of tips and improvements for the rig. So this is shaping up to be an ambitious project, maybe even more so than the HW-101 that I restored. Now, most of the work that I did on that was cleaning, whereas here I've got to repair or reconstruct or rebuild a lot of the internal circuitry. But I do like taking on challenging projects, even more so when it's a piece of classic amateur radio gear that's worth a little time and effort to make work again. So I do hope you'll stick with me on this series as I go through repairing this DX60. And as always, I hope you're enjoying the content on my channel. So until next time, bye for now.